So we know how to solve for variables when the variables are your bases, right? We know that we do opposite operation, right? And we've always done things like, we just did that question, right? Where you have 900, even 100, right? And then 1 plus I to the power of 5. And we were able to solve for I because I is in the denominator. Okay? I not in the denominator. I is the base. So now we're going to look at exponential functions, and we're going to look at exponential equation, and then we're going to see how we are going to solve for that. So first, let's define an exponential equation. An exponential equation is an equation that contains a variable in the, from grade 11, in the exponent.
Oh, really?
Yes, that's why it's called exponential.
I just said it.
So an exponential equation is an equation that contains a variable in the exponent, right? So if I have, let's say, 2 to the power of x equals to 16, right? You see that my exponent is the variable, okay? So I have to figure out how to find that x, how to solve for that x. No.
The square root of 16?
You can't do square root because the exponent is not square. So here it is, the trick for this. You can't divide, you can't do the square root, you have to do something. So to solve for this, some of them are easy, like this one is pretty easy. Because all what I have to do is I have to figure out 2 to the power of what gives me 16. So I have to make sure that my bases are the same, right? So give me 2 to the power of what? So on your calculator, you're going to do this and check. 2 to the power of 2 is going to give you 4. 2 to the power of 3, that's going to give you 8. 2 to the power of 4, that's going to give you 16, right? So what I do here is I actually rewrite 16 as 2 to the power of 4. So you see now I have the same base, 2 and 2. So that means my exponents are exactly the same. Because if 2 to the power of x equals 2 to the power of 4, then x is equal to 4. Right? So this is making sure that both sides have the same base. And if both sides have the same base, then the exponents are equal. Okay? So some exponential equation can be solved without technology by writing both sides of the equation as powers of the same base. So we're equating the power. So what that means, or in general, if a to the power of m is equal to, that right away makes my m and n equal to each other. Right?
What will common base is?
Because you have a common base. That's right. As long as a is greater than 0 and cannot equal to 1. A has to be greater than 0, and a cannot equal to 1. Why is that? Why a cannot equal to 1? Okay, let me show you something. Let me show you something. 1 to the power of 10 is what?
1.
How about 1 to the power of 20?
I think 1.
But is 10 equal to 20?
No.
They're not, right? So that's the only case that does not work, right? So that's the only case it does not work because 1 to the power of anything is 1, but my exponents are not equal to each other. Right? So if you look at this example, I have 4 to the power of 4 to the power of 3. So that means x is equal to 3, right? So what I say, I always tell my students, drop the base. Drop the base, and then that would make x equals to 3, right? So, since 4 to the power of x and 4 to the power of 3 are both powers of 4, the exponents must be equal. So the solution to 4 to the power of x equals 4 to the power of 3 is x equals to 3. Now sometimes the equation is already given to you as the same base. Sometimes you have to make them the same base. Okay? So let's look at this example.
Can you think of Caesars?
Yeah. A, 5 to the power of x equals 5 to the power of 6. So x equals 6, right? This is an easy one because the base is already the same. How about the next one?
2 times.
2 to the power of 5 gives you 32? Okay. So how do you find that? You just have to do it in the calculator, right? You have to actually put it in the calculator until you get that 32. You know that your base has to be 2, right? So you sit and to the power of 4, to the power of 5, whatever, until
You
you
have
get
to write it for the answer.
Yeah, and then,
Equals 2, 5.
yeah, so then you say x equals 4. That will be your final answer. All right, 2 to the power of x equals to a half. Negative 1?
Point.
How would I write? How would I write?
Or you write notes.
How would I write the right side? How would I write the right side as 2 to the power of something?
Then you just round negative. Couple of negative ones.
Negative 1 is.
2 to the power of negative 1, right? 2
32.
to the power of negative 1,
Why?
right? So, because when I have a negative exponent, if I want to make it into a positive exponent, what do? I flip, right? So if I have this, if I want to write that as a positive exponent, that's 1 over 2 to the power of 1, or 1 over 2, right?
But wouldn't you just write it like that? I think that's the more proper way to write it.
Yes, but I want to solve for now. That's what I care about. I don't care about the proper way. Look here. I want to solve. I want to make sure that my bases are the same, right? And my base on the left side is 2. So I have to make my base on the right side to be 2. And that's 2 to the power of negative 1. No, what's your solution? So x equals to what? That's it. And that's why I wouldn't want you to do this stuff and base stuff. How about the next one? So what would be your base? What your base have to be? 2. And then for the base to be 2, 2 to the power of what gives you 4? 2 to the power of 2. Now this is still not the same, so I have to make it base of 2, so I have to flip and make my exponent negative. So that's going to be 2 to the power of negative 2. So what's x? What's x?
Negative 2 minus.
It gets more.
I get complicated, not fun.
It gets more.
Ew.
I want to say funner, but
What is
funner is not a word.
What is that?
More fun is the word. This is more fun.
More fun. More entertaining.
What is this?
You're still doing the same thing. Make sure that your bases are the same. So what would be my base? What should my base be?
7.
7 to the power of what gives me 49?
3x minus 4. Like,
7. I mean,
7 to the power of what gives me 49?
3.
7 to the power of
3 mix? No, that's not bad.
20
7 squared plus.
squared. Right? So that's 7 squared. Now, look at this.
Do that thing then.
I have the same base,
I turn this up.
so I can drop the base and I can keep my exponent equal to each other and solve. 2 plus 4. And then divide by 3, so that gives you 2. I ask a question, you jump to the answer. Thank you. I leave my stuff everywhere, you know. I ask them a question, they jump to the final answer.
They're smart.
Yes.
You're doing a good job.
I would like to think so.
What?
So I'm still up in the air what that means. Yeah, this, yeah.
You smell food? Yeah, because they're having a potluck now. No, you're not invited.
It's okay, I'm gonna make whole chicken salad.
All right. How about the F? What would be my base?
Short of my base.
3. 3 to the power of what gives you 81?
6, 8.
You have to use your calculator. You can't guess and check. Guess and guess. 3 to the power of what gives you 81?
Oh, not 12.
I hope not. What is it? 4.
Just drop the base and go with it.
Okay, now
Just drop the base.
just drop the base. Make your exponents equal to each other. Who's watching the basketball game tonight?
Who's playing?
Tonight they're gonna
Quiet, follow the ball.
why?
Quiet, follow the ball.
I didn't pull my outfit.
It's giving the other the new dudes more chance to.
So cool now.
She said,
Forgot I was recording.
I'm sure this is not kids. All right, what do I do now? I
it's like term space.
Plus 4.
Plus 4.
bring the negative 4 over, and then
And 9 grade.
divide by 2.
The one.
4.
All right. So we're still like in the fun part, okay? Where we're just changing one side.
Miss, what is this?
X equals 3.
Suspicions
Oh,
were
Oh, don't you have to find a common denominator? So you
You don't have a denominator.
have to find like a common base.
Common base, yeah, common base.
How much is this easy, Miss Man? It's like it'll be
No,
5x
common
squared.
denominator is a denominator where you have a fraction. Common base is when you're base.
Yeah, what
Is it
actually?
gonna be 5x squared, Miss? Plus 8?
Okay, relax, don't jump.
Look at Johnny boy.
Whatever you use the base, you have to use the exponent. Is that it? No. She's like, what the fuck?
All right,
Ow.
3 is my base. 3 is my base. Yeah. Okay, so how would I change 27 to 3? 3 to the power of what? 3 to the power of what gives me 27?
Miss 3, Miss.
Okay, eyes on me because a lot of students get this wrong. Okay, so I changed 27 to 3 to the power of 3. But I still have that power of x. Don't forget that power of x that's out there. Okay? Now, I have 3 to the power of 3 to the power of x. What is that? How can I simplify that with the exponent laws? Power to the power.
Add it, Miss? Times it, Miss. My bad, times it.
Multiply. So I have to multiply this, right? That's right. So I have 3x plus 8 equal to 3 to the power of 3x. Right? Now, if you guys look at this, I have the same base. Now I can drop the base and then keep my exponent, make them equal to each other. So 5x plus 8 equals to 3x. Bring the like terms to the same side, right? So in this case, I want to bring the 3x to the 5x, bring the 8 over. So you see, brought the 3x over, brought the 8 to the other side. So 3x becomes a negative 3x, and 8 becomes equals to negative 8. 2x equals negative 8,